Hi, my name is Sawan Patel, and our project was on study of dataset on diabetes from 130 US hospitals over 10 years.
My name is Chan.
Jenny.
Harsha.
The dataset consists of over 100,000 records of patients diagnosed with diabetes, with records from over 130 hospitals all over the United States over a span of 10 years. Some research that was conducted using this dataset is called the impact of HbA1c measurement on hospital readmission rates. The authors of this paper used a statistical model and came to the conclusion that the correlation between the HbA1c measurement and the readmission depends on the primary diagnosis of that patient. They also suggested that giving more importance to the HbA1c result would help improve overall patient care. Some questions we would like to answer using this dataset is whether we could predict readmission of a patient given certain attributes and whether there are any associations between the diabetic medications administered to the patients during their hospital stay. Proceeding to our exploratory analysis, there are over 101,766 patient records, each consisting of 55 features per encounter. Some of the features include 3 separate diagnoses, a primary diagnosis and 2 secondary diagnoses, 24 medications, 6 of which are combinations of the other 18, readmission, meaning whether the patient was readmitted within less than 30 days of the previous hospital stay, more than 30 days, or if there is no record of readmission. The 3 diagnoses features consisted of ICD-9 codes correlating to that patient's specific diagnosis. As part of our pre-processing, we grouped the ICD-9 codes and diagnoses into which body system they affected, which for all the diagnoses, as you can see, is the circulatory system. Also part of the pre-processing consisted of dropping the weight, payer code, and medical specialty columns, as they were all missing over 50% of the data. We also dropped encounter ID and patient number because they were both unique numbers and wouldn't add any value to the research. We performed one-hot encoding on our data because it consisted of a significant amount of categorical data.
Next, we tried to find out associations present, if any, in our dataset. We took the homework script as a basis to convert the CSV file to ARFF format. We modified the script to account for the missing values. We were able to identify 2 association rules. It suggested that metformin can improve the insulin sensitivity. Association rule insulin gives metformin suggested insulin is widely used medicine for both type 1 and type 2 diabetes.
Next, we tried to build a logistic regression model to predict the probability of readmission. The original dataset has over 100,000 records. After pre-processing, each record has 242 features. Of all the records, only about 10% were readmitted. The rest were not. So this dataset is highly biased because the majority were negative. To balance the positive and negative data, we randomly selected 12,000 records that are not readmitted, combined with the readmitted data. Then we split the new dataset into the training data and testing data. Use the new dataset, we trained a logistic regression model. The model has an accuracy of 56.57%. Then we applied PCA to reduce the dimensionality from 242 to 6. This preserved 48% variance in the original data. Used the low-dimensional data, we retrained the model, and we found the accuracy was improved to 60.64%.
In addition to logistic regression, we also applied a random forest. Random forest is a ensemble learning method for classification. It constructs a large number of decision trees on the training data to create a classifier model. We apply this model later to the test data for prediction. Initially, we try to load the data and then drop on unuseful feature columns, and then later, as we discussed in the exploratory analysis, we mapped the ICD-9 values of the some of the features like diagnosis 1, 2, and 3 to their respective body systems. We also, as part of pre-process, we also mapped the categorical feature from the string values to the respective numerical values, so that it's easier for the random forest to classify them. And then, as Chang expressed in his previous slide and the logistic regression, the data was mostly biased towards not readmission. So we use the same procedure as we did it in the logistic regression. Later we used the random forest model to fit the classifier, and then use the model to classify the test data. Results that we got from by applying over 44 features of training data was an accuracy of 51.19%. In conclusion, we applied both unsupervised and supervised algorithms and then found interesting association rules from FP growth. From the initial exploratory analysis, we realized that the dataset is mostly suited for supervised algorithms. We applied unsupervised algorithms in conjunction with the supervised algorithms to enhance the accuracy of the models. Thank you.